For 15 years, display manufacturers prioritized a single metric, maximizing wide viewing angles. The goal was to ensure screens remained clear from any perspective, allowing multiple people to see the same content at once. But as smartphones became repositories for banking data and security keys, that wide visibility became a vulnerability. If a screen is clear from a 45-degree angle, it is open to visual hacking, what security researchers call shoulder surfing. The traditional response to this has been the aftermarket privacy screen, a polarized plastic panel applied over the glass to narrow the light's path. These protectors force a permanent trade-off. Because the plastic is always there, it degrades the OLED panel's brightness and color accuracy 100% of the time, even when the user is alone and doesn't need the privacy. Smartphone manufacturers are now moving the security layer off the surface of the glass and into the internal pixel architecture, allowing the privacy effect to be toggled on or off electronically. This shift has started an engineering competition over whether to achieve built-in privacy through physical sub-pixel manipulation or through scalable software updates. Samsung's approach on the Galaxy S26 Ultra attempts to solve visual hacking by altering the physical structure of the OLED panel. Samsung's Flex Magic Pixel interleaves wide pixels that scatter light broadly with narrow pixels that use internal black matrix walls to funnel light straight forward. Activating privacy mode shuts off the wide pixels entirely, leaving only the narrow beams illuminated. In this mode, side visibility drops to under 0.9% at a 60-degree angle, rendering the screen effectively black to anyone not standing directly in front of it. But manipulating light at the sub-pixel level creates an immediate set of compromises, known as the hardware tax. Turning off half the pixels on a screen results in a 50% drop in effective resolution. It also leads to off-axis color shifting, whites turning pink or blue, and has been linked to red patch manufacturing defects. Physically narrowing the light path provides high security against bystanders, but it requires accepting a drop in display quality and manufacturing yields. Because hardware interventions are expensive, alternative manufacturers like Rain Technology are experimenting with electronic polarization films, while brands like Xiaomi are attempting to solve the problem through software. Xiaomi's HyperOS 4 approach mimics the effect of a privacy screen, using operating system logic rather than physical display changes. This software method digitally blurs 90% of the interface, leaving only a small, movable, clear window over the active interaction field. This scalable approach can be deployed via over-the-air updates to older budget-tier devices immediately. The limitation is physical. Software cannot change the trajectory of light leaving the screen, so a bystander standing close enough can still read the unblurred active window from an angle. Software makes privacy tools available at all price tiers, but it creates a digital mask rather than a physical optical barrier. Built-in privacy hardware is already expanding. It's scheduled to move across the entire Samsung S27 lineup and onto the large, highly exposed screens of Huawei's trifold devices. Patents from Google and Apple outline a system where the device manages its own viewing angle using sensor data, removing the need for a manual toggle. In this scenario, if a user opens a banking app on a train, the phone's GPS identifies the device is in a high-risk public location. Simultaneously, the front-facing camera uses gaze detection to identify any unfamiliar faces looking toward the screen from over the user's shoulder. Apple's patents describe microscopic liquid lenses inside the display module. When a sensor triggers an electrical current, they change shape, focusing wide light rays into a narrow vertical cone. This narrows the viewing angle in real time, blinding unauthorized bystanders before they read sensitive information. By integrating these liquid lenses and sensor triggers, manufacturers are turning screen security into a reactive, hardware-level function that no longer requires an external film.